Training just 10 layers of an AI beat training all 36 of them. Fewer layers, better result.
Hang on, how does doing less work make the thing better? That sounds backwards.
It does. So hold a number. Picture an AI as a tower with 36 floors. Text walks in the lobby at the bottom. The answer comes out the top floor. Take a guess. How many of those floors do you need to fix to match fixing the whole tower? Hold your number. And keep one eye on the ground floor, the lobby. It doesn't just fail to help. That matters later. So here's what's coming. A test that costs 0 extra effort and still beats the standard way. A single floor that, trained alone, makes the AI worse than when it started. And a pattern that showed up in every model they tried.
And why should anyone at home care about floors inside an AI?
Every chatbot and coding helper you use gets a final round of polish before it ships. A step that sharpens it at math, code, and following directions. This is about where inside the machine that polish actually sticks.
And I just assume it sticks everywhere. Every floor pitches in a little, so you train the whole tower. That's the obvious move, right?
That's exactly what everyone assumed, Eric. Nobody had checked. And when they finally did, almost all of the improvement came from a few floors in the middle.
Okay, so how do you even test that?
Clean and simple. Take a fresh AI, fix just one floor, let it learn, while every other floor stays frozen. Then measure. How much of the full improvement did that one floor recover on its own? Do it again for the next floor, and the next, all the way up. Across 7 different models and several training methods.
And one floor could really keep up with fixing all of them?
The best floors recovered everything the full training got. A few even beat it. The worst barely moved the needle. Best floor to worst, about 4 to 1. And here's the shape that fell out. Plot each floor by how much it helped. Lobby at the bottom, top floor at the top. The lobby and the penthouse barely move. The middle floors spike up, and a few poke right past the line marking the whole tower result. A clean hump, peaking dead center.
Okay, Juniper, but isn't there a boring explanation? Maybe the middle floors just change the most when you train them. More change, more improvement.
That's the obvious guess, and hold on to it, because it's the key to why this gets strange. They checked exactly that. If the middle floors won because they get renovated the most, you'd see them change the most during training. So they measured how much each floor actually moved. Every floor changed by about the same amount. The middle floors don't move more. They just have better leverage. Same renovation everywhere, but push on the right floor, and the whole building improves.
Wait, so the middle doesn't work harder, the good stuff already lives there?
Baked in before the polish even starts. Which is why they could skip the testing completely. Don't measure a thing, just train the middle floors by position. No extra work, and it still beat training the entire tower. So, your number from the start. How many of 36 floors to match the whole thing? One well-chosen middle floor gets most of the way there, and a small handful of the best ones beat the full job outright.
And the lobby, Juniper? The one you told me to watch?
The ground floor was the villain. Train it alone, and the AI got worse than before any training at all. It walked backward down the hill. Proof that not every floor is a helper. Some actively drag.
Though I'd hold that one layer is enough line loosely. A lot of those single-floor wins are squeakers, barely over the line. It's less, one floor runs the whole building, and more, the brains live on a few middle floors.
Fair, Eric. And even that softer version rewrites how we thought this worked. Nobody yet knows why the middle is special. That part's still an open door.
So here's one to argue about. If you found out a company polished just a thin slice of its AI instead of the whole thing, and it came out better, would that make you trust the model more or less?
Drop your take below. And if you like Research Made This Plain, subscribe. There's a new surprising paper waiting every week.
The thing to watch for? The study that finally explains why the middle floors run the show. When that one lands, we'll be right back here.